Hello and Assalamu alaikum. My name is Fakisha. In this video we will be implementing half adder, half subtractor, full adder, and full subtractor. And we will be making each circuit by using the gates, and one circuit will be of only NAND gates, which are universal gates, and the other will be of the other gates which are AND gates and OR gates or NOT gates. So first of all, we will start with the half adder. So here we have half adder with simple gates. I will be running simulation and we will compare this uh, adder with this truth table by giving it the inputs. So here you can see on I have run the simulation on when the inputs are both inputs are zero, the switches are off, our output is zero, that is LEDs are off. Similar in this NAND case, our inputs are 0 and output is 0, which in truth table we can see a half adder. The inputs are 0, the output is this is the sum, the half adder sum output is of this LED, and this is the carry output, which is showing us 0. So we were discussing what carry means and what borrow means in subtraction. So here if I give, here was 0 0, and here if I give 0 1, which means A is 0 and B is 1, our output is 1, the sum is 1. Similarly in this case, uh, sum is 1. And if I give them uh, 1 0, it is A is 1 and B is 0, A is 1 and B is 0, then the sum is 1. So here was sum is 1. So in this case, when both 1 and A and B are 1, when A and B are, sorry, A and B are 1, A and B are 1, we have a carry 1, which means it is 1 and 1 means come 2. So the sum becomes 0. In binary, we do not have 2. So the sum becomes 0, and that 1 uh, goes to the next one. And the next, it goes in the carry for the next input. So we will move on to our half subtractor. So here you can see if I open these both gates. So when our inputs are 0, that is A and B are 0, our the switches are open, so our output is 0. And if I make 0 1, uh, so if I make 1 0, that is A is on and here also is on, our difference between both is 1. And if both are 1, A and B both are 1, the difference between both are 0 and nothing is nothing is being borrowed. So if I make it 0 1 0 1, so our difference is 1. So now we will move on towards full adder and full subtractor. So over here we have full subtractor by using simple gates, and here using universal gates that are NAND gates. So if I zoom it a little more, so here if I run the simulation, so running the simulation, you can see when both the inputs are, so in full adder and full subtractor we have an additional input, that is borrow in full subtractor, and in full adder we have a carry in. So here you can see when both A and B are 0, that is A and B are 0, and borrow in is also 0, we have a difference of 0 and borrow out of 0. But if the borrow in is 1, we have the difference 1, and we have the borrow out 1, that is our LED is glowing. Similarly, in this case, you can also see our both LEDs are glowing. And if open this and make 0 1, that is B, I make 1, then also we have the difference 1 and the borrow out 1. And if B and borrow in are both 1 and only A gate is open, then we have the borrow out 1. You can see we have the borrow out 1. So what if all the gates are closed? What is our output? So you can see difference is 1 and the borrow out is 1. Similarly, in the truth table, if all the inputs are 1, difference is 1 and the borrow out is 1. So after this, we will move on towards full adder. So here's the circuit diagram of a full adder in front of you, which I have made in Proteus. So if I run the simulation and make it more clear for you. So this case is running, which is when A and B are both 1, and A and B are both 1, and the carry in is 0. So the sum is 0 and the carry out is 1. This is the same case we have seen in the half adder. So what happens if the carry in is also 1? So if carry in is 1, you can see the truth table, the sum is 1 and the carry out is 1. That means from A and B, we are getting one carry out, and this is also making a 1 for the sum output, which becomes it makes it 1. So if we try this case, then A is 1 and B and carry in are 0. A is 1 and carry in and B is 0. Carry in B is 0. So you can see our sum is 1, and if only carry in is 1, I open A and make carry in 1, open A and carry in 1. So still you can see our sum is 1. So here we have seen in this video, we have seen the implementation of um, half adder, full adder, half subtractor, and full subtractor by using simple gates and by using NAND gates, charge universal gate in Proteus, and have simulated them and check our outputs by comparing them with the truth table. So that was it from this video. Thank you very much.